Hello dear learners, welcome to Module 7 on electrical house wiring in our online course on electricity and electrical wiring. I am Dr. Gitu Das, Department of Electrical and Electronics Engineering, Assam Don Bosco University, Guwahati. This module is divided into 4 sessions where we will explore the key concepts and components of electrical house wiring over the next 4 lectures. This module is structured as follows. In the first 2 lectures, we will cover the basic concepts of house wiring. The third lecture will focus on various wiring systems employed in residential applications. Finally, the fourth lecture will introduce the tools commonly used in house wiring. Now for today's session, we have the following learning objectives. So by the end of this lecture, you should be able to understand the fundamentals of electricity generation, transmission and distribution. Next, we are going to identify the various types of distribution systems used by electricity supply authorities. Then, the next objective is to recognize the different types of service connections available, and then we'll be becoming familiar with several common electrical accessories utilized in house wiring. So with these objectives in mind, let us begin. So what exactly do we mean by house wiring? Every home has a variety of appliances and equipment that require electrical power. The Electricity Supply Authority brings power up to the energy meter at the consumer's premise. From there, this power is distributed to each appliance and piece of equipment through a network of cables and electrical accessories installed throughout the home. This system is called electrical house wiring. In simple terms, house wiring is the distribution of power within the consumer's premises. Now before we go further into the details of house wiring, let us first take a step back to understand how electricity reaches the consumer. I hope you have gained some insights into this process in the first module. We will also discuss the different types of distributors that authorities use to supply power to consumers. Let's start with where electricity is produced. Power plants, also called generating stations. In these plants, we have generators that convert different types of energy into electrical energy. Power plants are usually located far away from areas where electricity will be consumed. There are several reasons for this. Firstly, it's often beneficial to place power plants close to natural energy sources. For example, hydroelectric power plants are usually built in areas where large amount of water at high heads are available. This is essential for driving turbines, which then drive the generators. Similarly, coal-fired power plants are ideally built near coal mines or other areas with an economical and constant supply of coal. This reduces the cost and logistical challenges of transporting fuel over long distances. Another reason for placing power plants away from populated areas is pollution. So when we burn coal, harmful pollutants are released. Building power plants which cause pollution near densely populated areas would pose health risks to the residents. Nuclear power plants similarly are also located in remote areas, often in low population zones. This is primarily due to safety concerns. We know nuclear plants always carry the risk of radiation leaks. So by placing them far from populated areas, we minimize the potential impact on public health. So you can see the power plants are strategically located to optimize resources, manage costs, and ensure public safety. In India, power generation typically takes place in 3-phase 50 Hz, often at a voltage of 11 kV or 11 kilovolts. However, Since generating stations are usually far from consumers, it's not practical to deliver power at this voltage over long distances. To overcome this, power is delivered in two main stages: transmission and distribution. In the transmission stage, the generated voltage is first increased or stepped up to higher levels, typically 132 kV, 220 kV, or even 440 kV or higher. This is done using step-up transformers. Once at a high voltage, the power is then carried across long distances by a network of three-wire transmission lines and towers. The transmission power is received at substation where the voltage is reduced to levels such as 33 kV or 66 kV. From these substations, power is further carried through three-wire transmission lines to various substations in and around urban areas. Now, the distribution stage begins at these substations. At these substations, the voltage is further stepped down to levels such as 11 kV, 6.6 kV, or 3.3 kV. From these distribution substations, power is then delivered to various distribution transformers, often located near roads or close to consumer premise. You may have seen these substations in your area. At these distribution transformers, the voltage is stepped down again to 415 volts. Power is then distributed to small and very small residential consumers through a 415 by 240 volts 3-phase 4-wire system or a 2-wire single-phase system. For large consumers, power is however supplied directly at 11 kV, 6.6 kV or 3.3 kV. Such consumers install their own substations. Here the voltage is stepped down to 415 to 40 volts. Now let's discuss the types of distributors used by electricity authorities to deliver power to the consumers. First, what exactly is a distributor? A distributor is a line from which connections or taps are taken all along its length to supply power to consumers. Distributors may consist of overhead bare conductors, overhead cables, or even underground cables. We can broadly classify the distributors into primary or high voltage distributor and secondary or low voltage distributors. The primary distributor mainly comprises of the three-phase three-wire system. The secondary distributor comprises of two systems, the single-phase two-wire system and the three-phase four-wire system. Each of these systems serves different needs and scales of power distribution. Let's start with the three-phase three-wire system. This system uses three wires, referred to as phase, live, or line wires. The voltage in a three-phase three-wire system is generally above 650 volts, with 11 kV being a common level. Due to its high voltage, it's also called a high voltage distributor or primary distributor. This type of distributor is mainly used to carry power from the distribution substation to various distribution transformers. These distribution transformers are normally installed along roadsides. Each of them supplies power to a number of small and very small consumers. Examples of small consumers are two-story or three-story buildings, small-scale enterprises, etc. Very small consumers are the small residential houses, local shops, etc. Large consumers, however, install their own distribution transformers. Examples of large consumers are apartments, shopping malls, hospitals, etc. Now, let's look at the single-phase two-wire distribution system. This system consists of two wires. The first wire is called the phase, also known as the live or line wire, and it typically carries a voltage of 240 volts. The second wire is called the neutral wire, which is normally at 0 voltage. This is a low voltage distributor or secondary distributor. The single phase two-wire distributor is commonly used to supply power to very small consumers. Now, let's discuss the next type of distribution system, the three-phase four-wire distribution system. This system is normally obtained from the secondary winding of the distribution transformers. This three-phase four-wire distributor consists of four wires. Three of these are called phase, live, or line wires, while the fourth one is the neutral wire. The neutral wire is at near zero voltage and is earthed at the distribution transformer. The voltage between any two phase wires is usually 415 volts, while the voltage between a phase wire and the neutral is commonly 240 volts. This is because the distribution transformer from which this system is obtained is normally delta star. So you see, the line voltage is √3 times the phase voltage. This type of distributor is also a low voltage or secondary distributor. This type of distributor is commonly used to supply power to both small and very small consumers. You see, the four-wire system is very versatile. It allows us to supply power to both small consumers who require three-phase supply and may have both three-phase and single-phase loads, and to very small consumers who need single-phase supply. This flexibility is possible because of the neutral wire. For single-phase consumers, we use one of the phase wires and the neutral wire to form a two-wire system. Now for small consumers with mixed loads, the three-phase loads are connected across the three phases, while single-phase loads are connected between a phase and the neutral. In this system, it's important to distribute the single-phase loads equally across all phases. This balance helps avoid issues in the power system. Therefore, when a consumer uses a three-phase four-wire system, it's the responsibility of the house wire designer to ensure this balanced distribution. On the distributor side, it is done by the supply authorities. Dear learner, now let's take a moment to review what we have learned so far. I encourage you to pause the lecture here and try answering the following questions before moving on to the next topic. So far, we have covered how electric power is generated at power stations and transported close to consumer premise through a network of transmission and distribution line. Now, let's look at how this power finally reaches the consumer's internal wiring. This connection is made using lines known as service mains or service connections. The service mains are responsible for bringing power from the supplier's low voltage distributors to the energy meter or the incoming panel at the consumer's premises. Service connections can be provided either by underground cables or by overhead conductors or cables. The choice is dependent on many factors. Let's start with the underground service connection. An underground service connection uses insulated armored cables and is commonly used in urban areas, suburban developments and locations where overhead service connection is difficult or not possible, or in cases when aesthetics are a priority. This type of connection avoids the visual impact of overhead wires crossing consumer premises. Underground service connections are also used when the consumer's load exceeds 25 kilowatt. Now let's look at the process of providing underground service connection when the supplier's distributor is also underground. In this system, the service cable is tapped into the supplier's distribution line using a T-joint, which is enclosed in a cable joint box. To install the cable, a trench is first dug and the cable is laid inside. A layer of sand is placed over the cable, followed by a layer of bricks for added protection. Finally, the trench is filled back with earth. At the end of the trench, the cable is brought above the ground through a galvanized iron or GI pipe, which protects the cable from mechanical damage. The cable then terminates at the consumer's energy meter or incoming panel. Next, let's discuss the process of providing underground service connection when the supplier's distribution is overhead. In this case, the service cable connects to the overhead distribution lines via a cable joint box mounted on the supplier's distribution pole. From the joint box, the service cable runs down the pole through GI pipes, which provide mechanical protection. Once the cable reaches the ground, it is routed underground through a trench covered by a layer of sand and protected with bricks and earth. Finally, the cable rises from the ground through a GI pipe to the consumer's energy meter or incoming panel. Now, let's move on to the overhead service connection. An overhead service connection uses overhead cables or conductors to supply power to consumers, with these cables typically supported by utility poles. There are two main types of overhead service connection. One that uses PVC or weatherproof cables, and another that combines bare conductors with cables. Compared to an underground service connection, an overhead service connection is more affordable, but it is also more prone to faults and less visually appealing. The overhead service connections are primarily used in rural areas. Now, let's discuss each type. Now let's discuss the process of providing overhead service connection using PVC or weatherproof cables. So in this system, a GI pipe is first raised above the consumer's premises. The height is set as per the requirements of the Indian electricity rules. A GI wire of at least 8 SWG is then stretched between the supplier's distribution pole and a clamp fitted to the GI pipe. This GI wire provides mechanical support for the cable. Next, a weatherproof or PVC cable is clipped along the GI wire. One end of this service cable is connected to the supplier's low voltage distributor, while the other end is brought to the consumer's energy meter or incoming panel through the GI pipe. To prevent rainwater from entering the pipe, the upper end is bent downwards. Now let's look at the second type of overhead service connection, which uses bare conductors. In this setup, a GI pipe is first raised above the consumer's premises. Next, shackle conductors are clamped to the pipe at an appropriate height. The bare conductors are then brought from the nearest distribution pole to these insulators. From there, connections are made using weatherproof or PVC cables, which are then routed through the GI pipe to the consumer's energy meter or incoming panel. So this completes our discussion on how electricity reaches the consumer's premises. Now the next phase involves distributing the received supply to the various appliances and devices within the premise, a process known as house wiring. Now that we have covered how electricity reaches the consumer's premises, let's move on to the next important phase, house wiring. Proper house wiring requires a variety of electrical accessories, each serving a specific function to ensure safety, efficiency, and control. These accessories can be categorized based on their functions as controlling accessories such as switches and fan regulators. Controlling accessories allow users to control the power supplied to the devices. Then we have the safety accessories like MCBs, that is miniature circuit breakers, and ELCBs, that is earth leakage circuit breakers. They are essential for protecting circuits and equipment against electrical faults. Next are the supply distribution accessories such as distribution boxes. So they help manage and route the electrical supply within the premises. And lastly, the general accessories like lamp holders and ceiling roses. They are necessary for connecting and supporting various electrical fixtures. Now, each of these accessories is made up of conducting and insulating materials. The conducting part limits the permissible current and the insulation limits the permissible voltage. So, the conducting part of an electrical accessory is typically made of copper or brass. Each accessory will have a current rating and a voltage rating. The current rating of an accessory depends on the maximum current it can safely carry without causing damage. For instance, if a switch is rated for 15 amperes, it means it can safely handle up to 15 ampere of current. However, if a higher current flows through it, the switch could overheat or even burn. This is due to sparking or other hazards. In a similar way, the voltage rating of an accessory is determined by the maximum voltage that its insulation can withstand safely. This means that choosing the right accessory requires a clear understanding of both the current and voltage levels present in the circuit. Alright, let's now discuss a few important electrical accessories. You see, there are a large number of electrical accessories used in house wiring. but we will focus on the most important ones. Let's start with the single-way switch. Single-way switches are commonly used to control electrical loads from a single location. They typically feature two terminal screws. One terminal connects to the live wire and the other connects to the load. Single-way switches are available in various current ratings to suit different requirements. They also come in single pole and multiple pole. The 6 ampere single pole switch is the most common one for controlling smaller loads, while the 16 ampere and 20 ampere are common for controlling power appliances. Next, let's discuss the two-way switch. The two-way switches are commonly used to control electrical loads from two different points independently. For example, staircase lights, hallways, or large room lightings. By flipping the switch at either location, the circuit can be opened or closed. A two-way switch has 3 terminals, common, L1 and L2. Now let's move on to the bell push switch. A bell push switch is a momentary switch typically used for doorbells. When pressed, it completes the circuit, triggering the doorbell to ring. Next, let's talk about the 3-pin socket outlet. A socket outlet is an electrical outlet designed to accommodate devices or appliances that uses a 3-pin plug to draw power. It has 3 slips. 2 of them are thinner in cross section for the phase and the neutral connection, while the third thicker slip is used for earthing connection. Then we have the 3-pin plug. A 3-pin plug is an electrical connector used to tap power from the socket outlet. It has 3 prongs or pins, which are designed to be inserted into the corresponding holes of a 3-pin socket outlet. Next is the fan regulator. A fan regulator, as you know, is used to control the speed of ceiling fans. Fan regulators use different technologies to control the fan speed, the common one being the regulator using the diac-triac combination and regulator using multiple capacitors. Now let's move on to the switchboard. A switchboard is an electrical panel that contains switches, sockets and other control devices. It allows the user to control individual appliance or equipment within the electrical system. You see, the sizes of modern switchboard, which use modular switches, sockets, etc., are given in terms of modules. For example, a one-way switch typically occupies 1 module. A 3-pin socket takes up 2 modules. And a fan regulator are available in either 1 or 2 module sizes. Therefore, the selection of a switchboard requires prior knowledge of the devices that need to be controlled from that particular switchboard. Now, let's talk about the ceiling rows. Ceiling roses are used to provide tapping for electrical appliances through flexible wiring. They are typically used for connecting loads like ceiling fans and exhaust fans. Now moving on to lamp holders. A lamp holder is an electrical device used to secure and connect a light bulb to the building's electrical wiring. It usually consists of a base which is mounted to the wall or ceiling and a socket where the light bulb is screwed in. Next is the combined switch and socket unit. A combined switch and socket outlet unit integrates a switch and a socket outlet into one device. This allows users to control the connected device with the switch while providing power through the socket outlet. Next we have the fuse unit. The fuse unit is a safety accessory in the electrical system. It is basically used to protect circuits and devices from overcurrent and short circuits. It consists of two parts. The first is a porcelain base which is fixed to a support such as a wall. It has two fixed contacts to which the incoming and outgoing cables of the live wire are connected. The second part is a porcelain carrier that holds the fuse element. This part can be detached from the base. When the current in the circuit exceeds the fusing current, the fuse element melts, interrupting the power supply to the faulty circuit. The fuse element is now gradually replaced by alternatives like MCB, which is the miniature circuit breakers. However, the fuse unit has its own advantages too. Now let's discuss a very important and essential safety accessory in house wiring: MCBs or miniature circuit breakers. The MCBs are electromechanical devices used to protect electrical circuits and devices from short circuits and overloads. They have largely replaced the fuse units in modern electrical installations. They also serves as the main switch fuse unit in many low power electrical installations. MCBs are available in various combination of poles, current ratings and trip characteristics. According to the number of poles, the MCBs can be classified as single pole or SPMCB. Single pole MCBs are normally connected to the live wire of sub-circuits. Next is the single pole and neutral or SPN MCB. This type of MCB disconnects both the live wire and neutral wire in case of faults. However, it can detect fault in only one of the two poles. Next is the double pole or DP MCB. This type of MCB also disconnects both the live wire and the neutral wire. However, compared to SPN, it can detect fault in both the poles. We normally use them at the incoming of the distribution box or at the outgoing to other distribution boxes. Next is the triple pole or TP MCB. These MCBs are used for three-phase circuits. It allows protection of the three phases. Next is the triple pole and neutral or TPN MCB. This type of MCB disconnects both the live wires and neutral wire during faults. Lastly, we have the 4-pole or FP MCB. This type of MCB also disconnects both the live wires and neutral wire during faults. However, compared to TPN, it has protection in all the 4 poles. This MCB is also normally used at the incoming of a 3-phase distribution box or at the outgoing to other 3-phase distribution boxes. Alright, let's talk about the distribution box next. So the distribution box is also called as a distribution board or breaker box. This is an electrical enclosure that houses and protects components like MCBs, ELCBs and other devices. The main function of the distribution box is to distribute electrical power to different circuits. It helps organize and protect the electrical system. It is a key component in residential, commercial and industrial buildings. Distribution boards are available in different sizes, which are typically available according to the number of circuits it can control or number of modules it can hold. Also, they are available for both single phase and 3-phase system. So we have come to the end of the discussion on electrical accessories. We shall discuss about few more as needed in this course. Dear learner, it is now time for a self-check of what we have learned so far. Please pause the lecture and attempt the following questions. In this lecture, we started with a discussion on energy generation, transmission and distribution. Then we explored the various types of distributors used by supply authorities to provide power to consumers. After that, we learned how the supply is brought to the consumer's premise with the help of servicemen. Finally, we covered some of the important electrical accessories used in house wiring. In the next lecture, we will discuss the concept of sub-circuits and explore different type of circuit connections. I hope the information shared in this video has helped you enhance your knowledge of house wiring. Thank you.